In this tutorial, we are going to solve some questions under linear motion. So I've got a number of questions with me here. The first question is, in the equation, displacement is equal to initial velocity times time plus 1 over 2 acceleration t squared. What does the term half at squared represent? Now, the formula which we have, this is the formula which is coming from linear motion, equations of the motion. So s is the same as the distance. So in this case, we have been given that s is equal to u, initial velocity times t, half at squared. Now, this part here represent the distance traveled due to velocity. Okay, so ut represent the distance traveled due to velocity. That is the first part. Now the second part is it is half acceleration t squared. So this one shows the distance traveled due to acceleration. So this question is just saying, what does the term half at squared represent? So it represents the distance traveled due to acceleration. Okay, so in a case where you have been asked ut, so it represents the distance traveled due to velocity. The second part represents the distance traveled due to acceleration. That is it for the first question. So I have question 2, which is saying two cars live across road at the same time. One headed north at 50 kilometers per hour and the other east at 70 kilometers per hour. How far are they after 1 hour? Now, let's first understand the question. So if we are to understand this question, we have got two cars. Another one is going toward what? Toward north. Okay? Another one is going toward north. Okay? So they are together. Another one going toward north, another one going toward east, like that. So the one going to east is 70 kilometers per hour. This one is 50 kilometers per hour. Okay. Now we want to find how far are they after 1 hour. That is the distance. How far are they after 1 hour? Is the distance from that point all the way to that point. Okay. The best way to do here is to find the distance for this first part and also the distance for that one. Then we use Pythagoras theorem to find the resultant in this case. So the time is 1 hour. So I'm going to say the speed or the velocity is equal to distance over time. We want to find the distance, the velocity times time. So the distance is, we have been given the velocity for the first part, the one which was going toward north. The velocity is 50. The time is 1 hour. Now, in this case, there's no need of us converting 70 kilometers per hour to meters per second because I've been given the time to be in hour already. So if I do times, if I do the math, I'm going to find 50 kilometers. Okay, that is my distance now. Then now the distance for the second one is going to be, the distance will be equal to again v times t. So the velocity is 70 times 1 hour. So I'll be able to get 70 kilometers, like that. Now that I have got the distance in this direction to be 70 kilometers, I also have another distance in this direction here, which is 50 kilometers, like that. Our goal is to find the distance. How far are they after 1 hour? So it is now the distance from this point here, okay, the distance from this point all the way to that point. How can we find that? Let's denote this to be equal to the resultant, more like we're finding the resultant in this case, meaning that this is going to be our rx, this is going to be our ry. Okay, so to find the r in this case, which is the resultant, is going to be equal to the rx squared plus the ry squared. So this is going to be equal to, I'm going to have the x, which is 70 squared plus 50 squared. Then I put it in the square root. So I'm expecting my distance to be equal to 17 squared plus 50 squared. I'm getting 7,400. I get the square root of that. I'm getting 86. So 86.02 kilometers. So how far are they after 1 hour so the distance at that point is going to be 86.02. So you can say the distance is, so you can say the displacement, which is S, will be equal to 86.02 kilometers. That is it for the for this question. So if I go to the next one, which is the third one, which is what third force must be added to the following two forces to give a zero resultant? What does it mean? When we add all the vectors, we have three vectors. When we add them, we are supposed to get the resultant to be 0. The basic idea behind vectors is to know how to resolve each vector into x and y component. So in this case, I'm going to come up with a xy plane, which I'm going to call it a free body diagram. So if I do have my free body diagram here, okay, if this happened to be my free body diagram, now the first vector, the resultant has got 0, meaning that if I resolve this resultant into x, it's going to give me 0, because 0 times anything is 0. The ry will also be equal to 0, the y component of the resultant in that case. Okay, now the next thing is to put now the vectors which have been given. So allow me to denote vector A to be equal to 30 Newton, vector B to be equal to 40 Newton, vector C is the one we're trying to find. Okay, now vector A has got 200 degrees, which is 200 degrees is in the third quadrant, meaning that from this point to that point is 200 degrees. I'll put it there. Okay, I'll call this as vector A to be equal to 40, 30 newtons. The next thing is vector B, which I have, is 315. 315 is in the third quadrant, the fourth quadrant, sorry. I'll put it there. I'll denote this as my vector B to be equal to 40 Newton. Starting from here, going all the way until it touches the vector, that is my 315 degrees. My goal is to find vector B, okay, vector C, sorry, the one which when we add to these two vectors, we are going to get 0. The best thing to do here is I have to say, I need to add the x component and the y components on its own, then I find the magnitude of that vector. The best thing to do that, I'm going to say, the Rx, the addition of all the vectors in x direction is going to be the Rx. Now the Rx is equal to Ax plus Bx plus Cx. The Rx I have already because the resultant is 0. In short, the resultant is 0. So to find Rx is going to be R cos theta. So R is 0. 0 times, even if I don't know the theta here, 0 times anything is 0. Therefore, this part here will be 0. X is A cos theta. In x-axis, when I'm dealing with vectors, is always cos theta plus the bx is b cos theta. Since I want to find the c, I'll just say cx. So I'll say 0 will be equal to A in this case is 30 cos the angle which is 200 degrees plus B is what? Is 40 cos 315 plus Cx. Okay, so we'll say what is 30? 30 cos 200. So 30 cos 200, I'm getting, so it's going to be 0 will be equal to is negative 28.19. Okay, then plus what is 40 cos 315? I'm getting Okay, so I have 30. Let me just redo it. 30 cos 200 plus 40 cos 315. Okay, so I can do it one by, so 30 cos 200 is giving me negative 28.19. Okay, it's giving me negative 28.19. Then the next thing is I need to also do what is 40 cos 315. So if we do that, what are we going to find? So what we're going to have is 14 cos 315. I'm getting 28.28 plus cx. So if I add these two, I'll have 0 will be equal to, I'll say negative 28.19 plus 28.28. The answer I'm getting is 0.09 plus cx. So I shift this to the other side, I'll be able to get my cx to be equal to negative 0.09 Newton. So I'll just put it here, my cx will be equal to 0.09 Newton. Now we need to find the cy, meaning now we go to y component. To go in y component, I'll use now ry. I'll say my ry will be equal to ay plus by plus cy. So ry, since the resultant is 0, ry will be 0. So I'll have a sine theta plus, in y component we are using sine, is always, then it's going to be b sine theta plus cy. 0 will be equal to a, in this case is 30. So what is 30? Sine 200 degrees plus 40 sine 315 plus cy. So I have 0 will be equal to, what is 30? Sine 200. I'm getting negative 10.26 plus, what is 40 sine 315? This is giving me negative, so meaning there is negative 28.28 plus cy. So if I add these two, I'll have 0 will be equal to, if I add those two, I'll be able to get negative 38.54 is plus cy. I shift this to the other side, I'll be able to have cy will be equal to 38.54 to be my cy. Now that I have the x component and the y component of vector c, what does it mean? What it means there is that to find the magnitude, to find the third force is going to be c, I put an arrow, is either this is a vector, so we represent it by an arrow or in the modulus, like that. Don't just say c is equal to, that is now a scalar quantity. So I'll say c, the arrow on top, then the square root of cx squared plus cy squared. So my c will be equal to, I plug in the values now, I'll have my cx is 0. I think our cx was negative. Here I've put just 0. I think it was negative because we had 13 cos 200 plus 14 cos 315. Yeah, it was negative. So I'm supposed to put negative here. But here, even if I put negative, since it's going to be squared, it will not affect anything. Plus CY is 38.54 I square. So I'll be able to find my resultant of vector C to be equal to if I do 0.09 squared, I will just ignore the negative because negative will go, I'm squaring it. 0.09 squared plus 38.54 squared. I'm getting 1485.3397. The square root of this is 38.54. 38.54 Newton. So my vector, the third vector is that, but now a vector can't stand alone without the magnitude. I'm supposed to include the magnitude. So now what I'm going to do is I'm going to find the magnitude. To find the magnitude, check first the components. Okay. Now here, what we need to understand is this. Let me just explain something here. How do you know that the angle is going to be in the first quadrant? Here, the quadrant. We have the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. To know that this is the positive x-axis, positive y-axis, negative x, and negative y. To know that this force or this vector is going to be in the first quadrant, if the x component is positive, the y component is positive, that angle is going to be in the first quadrant. In the first quadrant, when you use this formula theta to be equal to tan inverse of the y component divided by the x component, when you plug in the values, okay, when you plug in the values, the theta you're going to find, that is the answer. When you find that x component is positive, y component is also positive. What if the x component is negative and the y component is positive, meaning it is in the second quadrant here? In this quadrant, that's where we can see that y is positive going there, x is negative here. When you find the theta here, what you need to do is you say 180 minus the theta. Then that will be now the direction, because we're measuring the angles from positive x-axis. The next thing you need to know is that when x is negative, the y component is also negative. The next thing you're going to see now is going to be in the third quadrant. In the third quadrant, that's where you see, that's why you are going to see that x is negative, y is negative. When you find the answer using this, then next thing you have to do is you say 180 plus the theta. Now you only use this. When you find that it's negative, you ignore the negative when plugging in the values here. Okay, you ignore the negative, forget about the negative, plug in the values, you find the theta to be positive. After finding the theta, then you follow these simple principles I'm giving you right now. Now, if the x is negative, sorry, if the x is positive, the y is negative, meaning it's in the fourth quadrant. In the fourth quadrant, when you find the theta, you say 360 minus the theta. As simple as that. So in this case, we want to find the direction of vector C. So to find the direction, the best thing to do here is, I'm going to say the x component is negative, the y component is positive. If the x is negative, the y is positive, then it is in the second quadrant. In the second quadrant, I need to say theta will be equal to tan inverse of cx or cy divided by cx. But when I'm plugging in the values here, I need to ignore the negative part. So cy I'll say is 338.54 divided by 0.09. Initially it's negative, but you ignore the negative. When I ignore the negative, then I'm going to say the answer I'm going to find here, since it is in since it is in the second quadrant, then you say 180 minus the theta we're going to find here. Tan inverse. So same. If I get my calculator, shift, then I click on tan, open brackets, 38.34. I divide this by 0.09. So I'm getting my angle to be 89.86, which is the same as just 90. Okay, or I can say it's 89.86, but I can just say the theta is equal to 90 degrees. This 90 degrees, what does it mean? What it means here is that I have to say 180 minus 90 degrees. Again, it's going to be 90. This is the direction of this vector, meaning it was going toward the north. Okay, so that is it for this question. So what third force? The third force which is needed in this case is the 38.54 newtons at an angle of 90 degrees. Then we are going to get the resultant to be 0. If you want, you can prove this by dissolving each vector into x and y axis and into x and y component. Add them if you are going to get the resultant to be 0. Okay. So I have another question, which is a force of 3 Newton act at 30 degrees to a force of 5 Newton. Calculate the magnitude and direction of the resultant force. So let's say we have the force here, which is 5 Newton. Okay. Another force is acting 30 degrees. 30 degrees can be somewhere here. Okay. That is 30 degrees. Now this guy is 3 Newton. From that point going there, that is our 30 degrees. So we have to resolve each vector into x and y component. The resultant will be from this point all the way to that point. That is going to be our resultant. So we can call this one to be vector A and that one to be vector B. Meaning, if I want to find the resultant, I'll say the Rx will be equal to is going to be the AX plus the BX. The Rx is the one we're trying to find, we don't know. The AX is going to be A cos theta, like I said, in x axis is going to be cos, plus B cos theta. Now, when the vector is going toward east, the angle is 0 degrees. Meaning that my Rx will be equal to my A is 5, cos the angle is 0 degrees, plus my B is 3, cos 30 degrees. So I'll say, what is 5 cos 0 is 5. What is 3 cos 30 is 2.598, which is just 2.6. So my Rx will be equal to, it's going to be 5 plus 2, is it 2.6, which is 7.6 newtons. Now I have my Rx to be 7.6 newtons. Let's find the Ry. To find the Ry, we now need to add the y component. The Ry will be equal to Ay plus By. So it's going to be the Ry will be equal to A sin theta plus B sin theta. So the Ry will be equal to my A, like I said. In y component, we are using sine. In x component, we are using cos. A is 5 sine 0 degrees plus B is 3 sine 30. So my RY will be 5 sine 0 is 0, 3 sine 30 is 1.5. So meaning my RY will be equal to 1.5 Newton. Now that I have the RY and Rx, I can go ahead and find the resultant. Let's get rid of this. So what I'm going to have now is I'll have my resultant to be equal to the square root of Rx squared plus Ry squared. So the resultant vector will be the Rx is 7.6 squared plus Ry is 1.5 squared. Okay, so if I plug in the values, I'll be able to have 7.6 squared plus 1.5 squared. I'm getting 60. The square root of 60.01. Then now, what is the square root of that? So the square root of that is 7.7466, which is just the same as 7.75 newtons. 7.75 newtons is the magnitude. Okay, that is my magnitude. So I'll put it here. The resultant is even here 7.75 newtons. The question is calculate the magnitude and the direction of the resultant R. To find the resultant, to find the direction, before you solve, you will be able to know where it lies. Is it in the first quadrant, the second quadrant, or the third quadrant? In this case, the x component is positive, the y component is positive. Definitely it has to be in the first quadrant. In the first quadrant, we don't do anything with the angle, we just get it the way it is. Okay, so there we go. Theta will be equal to tan inverse. So I'll say the Ry divided by Rx. So theta will be equal to tan inverse. The Ry is 7.75. The Rx, no. The Ry is 1.5. The Rx is 7.6. One thing we have to understand, since the angle falls in the first quadrant, the angle will be between 0 to 90. That is what we should know. If we find that the angle is out of this range, then that is not the answer. Then you have made a mistake somewhere. So I'll say theta will be equal to tan inverse. So, in fact, let me just plug in the values direct here. So I have 1.5 divided by tan. So you say shift tan inverse, then open the brackets. 1.5 divided by 7.6. You close the brackets. So I'm getting my angle to be theta to be equal to 11.16 degrees. This can be rounded off to 11.2 degrees. So the resultant of this vector R is 7.75 Newton at an angle of 11.2 degrees from the x-axis or from the horizontal level, okay, or above positive x-axis. So this is what I had for you. Check out the next video for more questions.